Laws of indices. You need this law of indices, especially when you start performing basic operations with standard form. So we are going to be applying it here. So, and then the word indices is from the word index. So indices is just the plural form. So it is index or power. Index or power. So we can express numbers in the form a raised to power x. So this a is the base, while the x is the index or the power. So anytime you have a number expressed this way, then it is expressed in indices. So you can have something like 2 raised to power 3. So 2 is your base, 3 is your power or index. Entering into laws of indices now. So the first law is the addition law. Addition law. So and addition law is a situation whereby you have with different powers on the same base. So anytime you have the same base and different powers, and then the operation separating the two is multiplication, then in this case you will take one of the base and then add your powers. So that is why it is called addition law. So you can call it addition law or multiplication law. So anytime you see multiplication of two indices and then they have the same base, then just take one base and then add the powers. That is addition law. So let's take an example on that quickly. So just one example. Let's say we have 2 raised to power 3 multiplied by 2 raised to power minus 4. I intentionally use that minus 4 so that you will not be confused when you see a negative number. So we have, in this case now, it's going to be 2 raised to power 3, then plus minus 4. So if it is a whole number, we just add the 2. So if it is 4, that will be 3 plus 4, which will be 7. But now it is minus 4. So it will be 3 plus minus 4. And then in this case, we have 2 raised to power 3. Plus minus, we change to minus. And that will give us 3 minus 4. That's 2 raised to power minus 1 as your final answer. Okay, so the second law of indices is subtraction law. And subtraction law is a situation whereby you are having two numbers with the same base that are dividing each other. So we have the same base but different powers, and the operation is division. So in this case, we are going to take one of the base and then we'll subtract the power. So that's why it is called subtraction law. You can also call it division law anyway. So the moment you have division here, you subtract. The first one we treated, if you have multiplication, you add. Now if you have division, you subtract. So a quick example on that. Example. Let's say we have 3 raised to power 7 and then divided by 3 raised to power 4. So in this case, we are going to have 3 raised to power 7 minus 4. And that will give us 3 raised to power 3. So you can write your answer, you can leave your answer in index form, you can write your answer in normal form. 3 raised to power 3 will give us what? 27. That will be 3 times 3, which is 9, times 3, which is 27. And another law of indices is the power law. So when we talk about the power law, that is when you are raising a number that is already in index form to another power. So we are having something like a raised to power x, everything raised to power y. So in this kind of situation, what you just do is a raised to power x times y. So that will be a raised to power x, y. So but using numbers now, let's take an example. Let's say we have 3 raised to power 3 raised to power 3. So this is going to be 3 raised to power 3 times 3, and that will be 3 raised to power 9. Simple. So another law of indices is the zero index. So I'm going to believe you must have heard that any number raised to power 0 is equal to 1. So how did we come about that law? That is what we want to look at now. So if you have a raised to power 3 divided by a raised to power 3. Now from the last law that we considered, this will be a raised to power 3 minus 3. And this will give us a raised to power 0. Now, but don't forget that if you have a number, let's say 2 raised to power 3 divided by 2 raised to power 3, this is going to give us, I want to write it now with the division line. So this will give us 2 raised to power 3 divided by 2 raised to power 3. So and if I do this, I'm going to have 8 divided by 8. So when you divide 8 by 8, what are we going to have? We're going to have 1. So the same way, if you use the alphabet, a raised to power 3 divided by a raised to power 3, this will give us a times a times a divided by a times a times a. So a divided a will give us 1, a divide a 1, a divide a 1. So we have 1 times 1 times 1, which is 1. 1 times 1 times 1, which is 1. 1 over 1 is equal to 1. So and then you don't forget that the same thing we solve here now that give us 1, the same thing we solve here to give us a raised to power 0. So that is why we say that any number raised to power 0 is equal to 1. So that's how we came about that law. Alright, so the next law is the negative index. So when we are still building on that division law or subtraction law, so both our zero index and our negative index, they are derived from the division and subtraction law. So from here now, if we have a raised to power 3 divided by a raised to power 5, this is going to give us a raised to power 3 minus 5. And that will give us a raised to power minus 2. Because we are removing a bigger number from a smaller number, so we are going to have a negative index. That's a negative power. Alright. Now, how did we come about this? If I write this in expanded form, I will have this a times a times a divided by a times a times a times a times a. So 3a up, 5a down. Now if I cancel out, this will be 1, 1, 1, 1, 1, 1. So everything at the numerator is exhausted. But in my denominator, I still have a times a. So that means I'm going to have, this will give me 1. 1 times 1 times 1 is 1. Divided by 1 times 1 is 1 times 1 is 1. Then times a times a. So a times a is the same thing as a squared. So if I multiply a times a by 1, I'll still get a times a, which is a squared. So we now have a raised to power minus 2, and it's the same thing as 1 over a raised to power 2. So that tells me that anytime we have a number raised to power negative index, let's say a raised to power minus x, is going to be the same thing as 1 over a raised to power x. So I'll just remove this negative sign the moment I divide 1 by the number I have here. So our a raised to power minus 2 is the same thing as 1 over a raised to power 2. We remove the negative sign. So the same thing is applicable here. So if you have, let's say, 3 raised to power minus 4. So this is going to be the same as 1 over 3 raised to the power 4. Remove the negative sign. Alright, so this will be the last law before we take one or two examples. So this fractional index is a situation whereby you have a power that is a fraction. For example, let's say we have a raised to the power 1 over 2. So a raised to the power 1 over 2 is going to be the same thing as square root of a. If I have a raised to the power 2 over 3, this is going to be the cube root of a squared. So the idea is your numerator is the power, your denominator is the root. So if you have 2 as your denominator, is square root. If you have 3 as your denominator, is cube root. If you have 4 as your denominator, that will be fourth root, and so on and so forth. So if generally now, if I have a raised to the power 1 over n, that is going to be the nth root of a. That's the general form. So example now. So let's first look at 36 raised to the power half. So 36 raised to the power half is simply going to be square root of 36, since our denominator is 2, and that will give us 6. Then the next one is, let's take this 27 raised to the power 2 over 3, and this is going to give us our denominator at the power side is 3, so that will be cube root. So that will be cube root of 27. Then don't forget that here our numerator is not 1. So anytime your numerator is not 1, you raise this number to the power of the numerator. So that's 27 squared. Okay, so from this point now, we are looking at cube root of 27 squared. So I can just first look for the cube root of 27, and that will be 3. And then I will now square that. So cube root of 27 squared will be 3 squared, which is 9. Okay, let's consider these two examples and the WAEC past question. So we can derive this, or we deducted this from WAEC past questions. So now we are going to be applying those laws. We know that 9 is the same thing as 3 raised to the power 2. Then raise it to the power 2x plus 1 equal to 81 is 3 raised to the power 4. Yes, so we have 3 raised to the power 4, that is 81. Then raise it to the power x minus 2 divided by, this is already in base 3, so just write 3 raised to the power x. So from here, we'll use our power law for this. So remember that when you have power law, you multiply the two powers. So that means we are going to have 3 raised to the power 2 multiplied by 2x plus 1 equal to the same power law. We are going to apply it here. 3 raised to the power 4 multiply x minus 2, then divided by 3 raised to the power x. So we multiply out this. We have 3 raised to the power 2 times 2x will be 4x plus 2 times 1 will be 2 equal to 3 raised to the power 4 times x is 4x minus 4 times 2 is 8 divided by 3 raised to the power x. So from here now, So we use our division law and subtraction law to sort out this. So we have 3 raised to power 4x plus 2 is equal to 3 raised to power 4x minus 8 minus x. So we have the same base, so we are now subtracting the powers since it is division. So from here now we have 3 raised to power 4x plus 2 equal to 3 raised to power 4x minus x will give us 3x, then minus 8. Okay, so now we have equality sign. So if we equate the powers, the 3 here, we cancel the 3 here. That means the base is out. So we are equating the powers now. So it means that 4x plus 2 is equal to 3x minus 8. So this gives us an equation now. It gives us an algebraic equation. So we can collect like terms. Collect like terms. And what do I mean by collecting like terms? The ones that have x, bring them to one side of the equality side. The ones that are whole numbers, take it to one side of the equality side. So we have 4x. So I want to bring this one here. It will change to minus because it is crossing the equality sign. Minus 3x equal to, so this 2, I'm taking it to this side. That means I will have minus 8. It is still at this side. This one is coming to meet it here, minus 2. So we have 4x minus 3x, that's x, 1x, equal to minus 8 minus 2 will give us what? Minus 10. And that's the value of x. So the last example we'll be considering in this module, we have 64 over 27 equal to 3 over 4 raised to power t minus 1. So the first step is to express the numbers here in index form, because what we have here is in index form, is raised to power of something. So we have to express this function to be raised to power of something. So 64 is the same thing as 4 raised to power 3. Then 27 is the same thing as 3 raised to power 3 equal to 3 over 4 everything raised to power t minus 1. So 4 raised to power 3, 3 raised to power 4. Since the power is the same thing, I can choose to write it as 4 over 3 everything raised to power 3 plus 3 over 4 everything raised to power t minus 1. Now, but when you look at this now, our base is 4 over 3 here. Our base here is 3 over 4. So the numbers are inverted. So I want to make it the same. So I will have to invert this one. And the moment I invert this one, my power will change to negative. So anytime you invert your base, your power will change to minus. So we now have 3 over 4 here. So it will now be raised to power minus 3 instead of 3, equal to 3 over 4 raised to power t minus 1. So the reason is because we want to have the same base. So the moment we have the same base, we can now equate our powers. So this base and this base will cancel out. We now have minus 3 equals t minus 1. So by collecting like them, minus 3 plus 1 will be equal to t. And that means t will be equal to minus 3 plus 1 is minus 2. This is solved.